So I actually have two presentations, but I'm going to show you my presentation first, and I'll show you the kind of fun part of what I did. Okay, so like I was introduced, my name is Joel Gonzalez Santiago. Originally, I'm from Puerto Rico, but I study right now at Elizabeth City State University. My study was actually done in Alaska, and again, it was for the temporal changes of surface elevation and velocity in Juneau Icefield. So, if you guys didn't know, Juneau is actually the capital of Alaska. That's something I found out when I got there. Interesting enough. This research was done in late June to early August. So some of you that might know about that might have some questions about that later, and I'll be sure to answer those. And you might think, why is a Puerto Rican, that's someone that lives in 80-degree weather, going to Alaska to study glaciers? That's very different for you, right? And yeah, it was something completely different for me, and I think that's the reason why I did it. I wanted something out of the box, not in a business office every single day. I wanted something completely different for myself. And I forgot to say that about myself. I'm actually a business major with a minor in GIS. So that's one of the reasons that I wanted to do something completely different. So the program that I was in is with the Juneau Icefield Research Program. They're the ones that guided me through it. I'm not going to go camping and skiing and all that stuff by myself. I've actually, before this trip, never gone camping, never gone skiing. The most amount of ice and snow I've seen was maybe an inch. So it was, like I said, it was very, very different for me to actually go and do that. It was actually started by Maynard and Malcolm Miller in 1948. He actually brought a couple of his students up to the Icefield because they had this issue at the time where they noticed differences on the Icefield, but during that time they were studying glaciers at the terminus, or at the very, very bottom of it. He proposed the idea of studying it up on the actual accumulation zone of the glacier, and that's why he went up there to do it, as well as he's an avid skier, and that's one of the things that he liked to do. It has over 60 years of studies on the Juneau Icefield, which makes it one of the longest running studies on the Western Hemisphere. And again, it's for educational and expeditionary purposes, which is one of the things that I really wanted to bring together. I wanted to be out of the office, doing something fun, and on my feet, learning at the same time that I was learning. We were learning how to cook. We were learning how to ski. Skiing was way, way different. And how to climb. I'm actually kind of a nerd, if you can't tell already. So for me to do these types of things, it was, again, out of my comfort zone, but I loved every second of it that I was up there. So does anyone know here what an actual glacier, or like what a glacier is? Just know, anyone want to answer that question? If not, I can say, okay. Basically, a glacier is basically a slow-moving mass of ice. And for me, that was interesting because I was like, oh, that's right. Glaciers move. And that's one of the things that we wanted to study for. And then we see within the past decades that it's been receding ever since. While it's still moving, this one has been moving backwards because it's having less and less ice and snow every year. This is the Mendenhall Glacier, which I'll talk a little bit more about on the next slide. And then Mr. Beetle is actually someone I got to study under on the Juneau trip itself, which I thought was really interesting. And so a lot of the world has actually been doing studies with the glaciers continuously, and that's one of the reasons that we did it there in Alaska. So the Mendenhall Glacier was really important for me specifically because this was the first glacier I'd ever seen. This is the first glacier I've ever been on. And it was during that field trip that we had to do it, which is our first study, our first, it was my first time on that ice. You can actually, when you go to Alaska, or if you ever go to Alaska, the visitor center is right here on the right side, and it's actually one of the places that I got to present my studies. And you have a beautiful, beautiful view right there. If you want to have a more up-close and personal type of view, there's a trail that goes from the left side all the way around, and then it just kind of opens up to the glacier. Once you get to the end of it, it's kind of like this steep, rocky kind of slope that just brings you down to the glacier. Once you're on the glacier, we had to put on our helmets, we had to put on our crampons. Crampons, I basically call them boot spikes for the entire trip. They're just spikes that you put on the bottom of your feet so that when you step, you stick right there. People use this to climb, and you can go on angles that I did not think was possible with this. Okay, so my study actually focused on the Taku Glacier, which is one of the only glaciers that's actually advancing, or previously was advancing, which is one of the interesting parts about it. It's over 3,000 square kilometers. It has over 50 outlet glaciers, and it's water terminating. Just like the last one I showed you, it ends at the water. If it's melting and it's ending at the water, that means that there's more water coming into the oceans, and with that we can get into a whole different topic, which I'm not going to discuss. So what we did is we focused on 12 longitudinal profiles, or center lines, along the Taku Glacier. A, being this really, really long one, was the one that I wanted to focus on. And then we also had over 10 transverse profiles, which are cross sections in longitudinal A. But I will focus on profile 4, which is right this blue one down there. So again, a very similar image. Our goals for this was to look at the velocity and to look at the elevation throughout the glacier. And what we wanted to do with our studies compared to the previous studies that have been done, to see if we find anything different, to see if we find anything significant. And one of the goals that we could not accomplish at that time, but we wanted to, was to find the Matthews-Llewellyn divide. The glacier is divided, I believe, into 3 parts, but we wanted to focus on 2 of them specifically. Just see if I can bring my mouse up there. Okay. So right here is where the grid is, and this side is the Matthews, and then the other side is the Llewellyn. And we wanted to see if we could find that divide. So how do we do it? Just like the previous people ahead of me, they also did things with the Temporal GPS. Temporal GPS is what it's called. We had to set up our base station every morning. We would get up, I think wake up was around 7 in the morning, and then if I was on that group for that morning, we would help set up with the base station, which had a rover on top, and this was quite the process to do. It's not as easy as just, clamp out and then just place it there and that's it. We were very precise in having a specific position, and it had to have good coverage throughout the area that we were going to be on. We wanted to measure points along the longitudinal profile, which I said before, and every point was half a kilometer from the previous one. So we can't travel half a kilometer by feet. I mean, you can, but it takes a long while. And with all the points that we had to do, it was better for us to use the snowmobiles, which you can see on the left side, and we had to carry backpacks with batteries on them for our equipment. So this was quite the different process for me. We didn't have the nice wheel that she had to go from place to place, so we had to hold it and make sure it was in the right position, make sure it was steady. We had a little a water ball lever. I'm not really sure what the name of it, but the little part that has the water in there, to make sure that was correct. Click the button, it would send the data back to the base station, and then afterwards we would collect that data and transfer it over to an easier file. One of the funny things about this is you actually had to carry this 2-meter stick that had the rover on it, and there wasn't a place to put it. So while we were on the snowmobile, we would have to carry it, being behind someone else, and try to not fall off because you're driving through ups and down hills of ice and snow. That was kind of one of the things that inspired one of the drawings that one of the Jerpers did. Sorry, Jerpers is the Juneau Icefield Research Program. We call ourselves Jerpers. So a lot of people would draw, and one of the things that they like to draw is kind of like this heroic pose of you holding this 2-meter pole on the snowmobile. It was one of the funniest things that we got to see while we were up there. So again, what we did is we actually, once we had that data, we transferred it back to spreadsheets. In Excel, we used ARC to making the maps that you guys saw in the previous slides. And we used a little bit of R programming language to do some statistical analysis on that part. And this is kind of what our classroom was like in some of this. Was a very tight little area. So for some of the results we have, this shows a plot of elevation for longitudinal A, and it shows the distances. Again, for every kilometer, we would have 2 points because every point is half a kilometer away from each other. And this is from the first point all the way to the left to the last point all the way to the right. The red line shows the year of 2000. The blue line shows the year of 2008. And then the green line shows our year, 2016. Now, why do we use 2000, 2008, and 2016? There's different amounts of snow for every single year that happens, so we can't just use 2000, 2001, 2002, 2003. That doesn't give us that accurate of a plot. We wanted to show the differences between that 8-year span. And then also the 8 years fit best with our data. I think the earliest data we had for the GPS part was in the 1990s for the Juneau Icefield research program. There are other programs that study things such as mass balance, erosion, and life on the ice field. This next graph is a very similar graph, but this one shows the change in elevation throughout the years. The blue line is from 2008 to 2000, and then the red line is 2016 to 2008. So as you can see, there's a much bigger difference between the same 8-year span at different times. There's a 5-meter difference between these two lines, and that's quite concerning for us to see. Global warming is happening, as most of us know, and this is the glaciers have kind of been a reaction to that. It's a good way to show that these types of things have been happening. And then lastly, I will show you the velocity graph that we found. So the blue line is the velocity that we found, and then the red line is the elevation. With velocity is distance over time. To find a distance, you need 2 points. So what we did for our transect profiles is we measured 1 point, we put a stick right there, which these sticks are like huge. We actually made them out of some wood material we had in old plastic bags. So we took that at 1 point, and then we waited 1 to 2 weeks, and then we measured where that flag was the second time. That gives us our distance, and our time was that 1 to 2 weeks. So we plotted it along the transverse profile, and as you can see, it's highest in the center. So that shows that it's moving the fastest in the center. And this, basically with our calculations, we found that in the center, it was moving 0.5 meter a day. That's pretty fast for ice to move. And this is also very similar to honey, because honey has that's very similar viscosity, where in the center it moves the fastest and on the edges it moves the slowest. The reason it moves the slowest on the edge is because it has friction with the land surrounding it. And the red line kind of shows you the elevation at that point to show you, so it doesn't really matter how the land is formed, it's always moving the fastest in the center line. So for the conclusion of it, there's been longer ablation or melting times, and there's been less accumulation times for these types of glaciers. The Taku, we actually found out, comparing it to the previous years, it's no longer advancing. And that's concerning because it's been advancing for a couple centuries now. And then, like I said before, the velocity is highest in the center when it comes to ice flow. For the future works of JERP, they want to continue to monitor the Taku Glacier because they've been doing it for 60 plus years now, and they're going to want to continue to do so. And then with the GPS group specifically, they wanted to locate the Matthew Llewellyn Divide, which I talked about briefly before because we were not able to do it in our span of time. So that's for that one, and I can get to the more fun one 1 second. I can also take questions at this time because this fun was just kind of showing what I did, what I experienced, and things of that sort.
I was going to ask you something about Florida sharks that you have profile A between the year 2000, 2008, 2016.
Mm-hmm.
Where in 2000 and 2008 was closed, but then you have this big gap between 2008 and 2016. Why is the gap so big?
The one before? Are you talking about this part on this side?
Right.
Ah,
From the beginning.
from the beginning.
Yeah. The data where why is so apart? No, in the end, this is the beginning.
Right. So again, this is the elevation at that point. At the beginning is actually at the terminus of the glacier, so it's at the very end. That's why there's so little snow compared to the rest of it, or so little accumulation compared to the rest of it. It's where ice basically goes to melt. And that's one of the things. Any more questions about the graphs before I switch?
Has the point of what was it again? The beginning of the glacier.
Terminus.
The terminus, has the terminus moved locations as it's melting back?
So for the Taku specifically, it hasn't moved back that much because it was advancing. It was actually moving forward. With our studies, we actually found that it stopped moving forward, and we're probably going to see it starting to retreat. So eventually, we might see things like this for the Taku Glacier. All right. So back to the other one. This is one of the field checks that we had to do. Before we went up there, we had a lot of gear that we had to use, and they had to make sure we had all of it. This is the group that I was part of. It was around 40 plus students. This is the group the first group I was with to actually get to our first camp. This is kind of like the field trips that we had to try it out before. Some of the beautiful greenery I saw, and some of the last greenery I saw for 8 weeks. Again, a lot of beautiful photos. It was like nothing else I had ever done before. Before this, again, I've never gone hiking, I've never gone camping. This obviously is what we had to deal with when we were up there. I didn't have cell phone, I didn't have any type of internet service. It was quite difficult for me to be up there as a student. This is a swill slope. This is where we threw organic material away, and this is what our kitchen was like. Very crowded, all together, but we always had a lot of fun. We had our Write in the Rains, these yellow books that are able to be written in the rain specifically, and this is what the first camp looked like. Again, beautiful scenery that I got to see almost every single day. That's our instructors skiing. This is one of the things I had to learn to do, was to ski on ice. And they said this was one of the hardest things to do because it's not, as you can see, it's kind of wavy. And this one specifically, we had to tie up at certain times where it was very dangerous for us to cross by ourselves. One of the nights we actually got to spend on the Icefield itself. We had to camp out on the Icefield. And we all kind of were relaxed once we got there. This is Red Dog. There's bomb shelter in the background. I believe this one is Petunia. All the outhouses had names. So it's a very different culture while we were up there. Some days we got to soak up in the sun. I actually used more sunscreen in Alaska on the Icefield than I ever have on living near the beach. I thought that was interesting. This was kind of our classroom. Very crowded, all together. Everyone was on the same point. Some of the cool things we did is we actually got to make our own food, and all the food was brought in by helicopters. This was my friend's birthday that day, so he got one of the bigger cinnamon rolls. We had to have a lot of fun on these types of things, so they included this in the security. This is part of the vegetation that I got to see while I was up there. And then the lectures. The lectures were some of the most fun because we were outside for some of them, we were inside for some of them. And again, this is like no other classroom I've ever been in. It was fun. We got to cook. Someone brought a kite up there so we could go fly at the same time. This is one of the camps that was on the edge of this Nunatak. And a Nunatak is basically a rock surface that's protruding out of the ice. One of the caves that we got to go into, there's a couple more photos that are up here on that. That's me when I was up there. My beard was a lot more full, and I had a lot of fun growing it out up there. And it was, again, like nothing I've ever seen before. This next photo is me at the end of the trip once we got to Atlin, British Columbia. One of our trips was to actually cut wood, so that's one of the things I did. Some nights we would spend it out on the riverside and just sleep right there on the docks. We had one of these very, very old stoves that we had to cook in where it was actually firewood. This was one of the days that we were coming back, and that's all of our gear on it. And this is when I had to present in Atlin, Canada. And if you want to how to apply it, this is a previous presentation I did. You can go on there, and any more questions about how I lived, what I did, was it difficult to ski, anything like that I can take. Sure.
You do up the food, did it draw wildlife or anything?
We actually saw a couple of wildlife there. They had kind of these Arctic chickens, is what they were. The actual name is ptarmigans. They look like doves, but they're not that bright, actually. One of the things that I did is that we would go and just capture them, pet them, and then put them back down and let them keep going. They weren't the smartest little animals. I think we saw a wolverine while we were up there. We weren't exactly sure. It was pretty far away from us. But we saw tracks of bears, brown bears, not grizzly bears. Grizzly bears is a tourist thing to say when you're in Alaska. And wolf tracks as well, while we were in the first couple camps that were close to the greenery. You had a question, back, sir? So, yeah, data has been collected for, like I said, since the early 1990s to our current year. Some years there's big positions that are just completely missing. Other years, their snowmobiles weren't working, so they couldn't take as many points as well. We were lucky enough to be able to take all of the points and have some extra days for processing ourselves. But it kind of changes year to year because they're kind of supported with a lot of their people that way.
It's a concern with how when you express it that way, and then that there's a lot of variability, and then you pick those years, brings the potential that you could have been cherry-picking years that made it look like a trend that you wanted.
Right. That's
just not saying you did.
No, you're completely right. That's one of the concerns we had because originally what I did is I took every single year. Afterwards, we did the average. The average was a big jumbled mess. Didn't show the data correctly, or yeah, it really didn't show it correctly at all because of the variances per year. The main thing we wanted to show was that it is melting, and with that, given the difference, it shows that that's a lot. Because between 2000 and 2008, there was almost no difference. And even if there is a snow difference, it's not going to be as substantial as you saw in that graph. It's going to be maybe a meter of snow difference. We saw over 5 meters differences. And that's not going to happen with just 1 year. Yes. Yeah, they were all between June to early August. Late June to early August, which I described that earlier being a weird time. That's a time when these glaciers are generally melting. But the reason why we can say that this is mostly accurate data is because all of our research has been done at this same time every single year. So because we compare it to the same time every single year, it should show very similar results.
Well, thank you.
All right. Thank you, guys.
Let's give all Maria, Andrew, and Joel one good round.